In today's lesson, we will be using the second derivative test to determine extrema. So, we'll be finding relative min and max and possibly an absolute min or max, which we've already done in this unit. So we're doing it again, but using a different method. So let's do a recap on what method we were doing before. When we were doing the sign charts, and we had the different intervals, and we would be looking at the derivative, signs of the derivative. So maybe we'd have a negative, 0, positive, 0, negative. And then we had to think about what that told us about f of x. So we did the decreasing, 0, increasing, 0, decreasing. So you can see there is this minimum point and this maximum point. Well, a minimum point happens when f of x is concave up, and a maximum point happens when it's concave down. So concavity we can get from the second derivative test. So we're going to be finding those points using the second derivative, and we don't even need to make a sign chart. Okay, so the second derivative test is if we have the first derivative at a point, if that equals 0, those are the critical points. So then to know if it's a relative min or a relative max, we would just have to know the concavity. So if the second derivative at that same point is greater than 0, then that means f of x is concave up. And if it's concave up, then there is a relative min. And then if the second derivative at that point is less than 0, f of x will be concave down, meaning there'll be a relative max. So it's that idea of critical points and then concavity to find our extrema. Okay, so here is an example. F of x equals x to the third minus 3x squared minus 1. Let's find the first derivative. 3x squared minus 6x. And we have to set this derivative equal to 0 to find the critical point. So first derivative, set equal to 0. I will factor out, let's see, a 3x. So I'm left with x minus 2. So critical points at x equals 0 and x equals 2. So in other words, the derivative at 0 is 0, and the derivative at 2 is 0. So now if we take the second derivative, that would be 6x minus 6. So now let's do the second derivative at these critical points. So the second derivative at 0, meaning we would have to plug in 0. 6 times 0 minus 6 equals negative 6. So the second derivative at 0 is less than 0. So that means at 0, f of x is concave down, meaning it has a relative max. So f of x has a relative max at x equals 0. And now same thing with the other critical point. Let's find the second derivative at 2. So just plug in 2. 12 minus 6 is 6. So the second derivative at 2 is greater than 0, which means f of x is concave up at 2. So it's a relative min. So that means f of x has a relative min at x equals 2. So just to recap, It's the second derivative test, which gives us information about the original function. Critical points use the first derivative. And then at those points, using those points, and the second derivative tells us about concavity. And then that will tell you the min and the max. Okay, so we're just going to do one more example. So this time, f of x equals x e to the x. So let's start by taking the first derivative. So we have to do product rule. Derivative of the first times the second plus the first times the derivative of the second. Let's set it equal to 0. I'll factor out an e to the x. So I'll have x plus 1. So that will never equal 0. So I'll have a critical point at just x equals -1. I'm going to write a special note here because this is important. This function has only one critical point. Only one critical point. I'm going to come back to that at the end. So let's take the second derivative. Okay, so if I'm looking here, this e to the x times, so in factored form, I'm going to do the product rule. So derivative of the first is e to the x times the second, x plus 1, plus the first, e to the x, times the derivative of the second, which is just 1. And then, so if I take the second derivative at the critical point, using that, -1, so e to the -1 times -1 plus 1 plus e to the -1, well, this will be 0, so this whole term cancels out. E to the power of -1 is a positive number, so the second derivative at -1 is greater than 0, meaning concave up, so it means there's a minimum point. But here is the special case, is if there is only one critical point, then we are dealing with not relative extrema, but absolute. So this is not a relative min, this will actually be an absolute min at x equals -1. So remember, it's the original function f of x has an absolute min. So there is the lesson. We're going back and we're finding the extrema, but instead of the sign charts, we're using that second derivative. Good luck with your lesson.